Welcome to the deep dive. Today we're getting into something pretty specific but really useful for home setups. Ever tried running an HDMI cable across a whole house? Yeah, not fun if the walls are already up.
Right. It's a common headache. Drilling, patching, painting. Nobody wants that.
Exactly. So we're looking at a neat bit of tech that gets around this, the HDMI Over Coax extender system.
Hmm?
Okay, let's unpack this. Our goal here is pretty straightforward. Figure out what this thing does, what it doesn't do, and, where it actually makes sense to use it, especially how it uses the coax cables you probably already have hiding in your walls.
What's fascinating here is, well, it sounds complex, but the core idea is simpler if you think about it the right way. You're basically taking that HDMI signal, modulating it, pushing it over that existing coax wire.
Just the standard copper wire.
Yeah, just the coax.
Yeah.
And then at the other end, it demodulates it back into HDMI. Simple as that conceptually. You really should just think of it as a very, very long HDMI cable, but, with a piece of coax cable stuck in the middle.
Okay, like a bridge.
Exactly. And it always comes as a pair. You've got the transmitter, the TX unit near your source, like your Blu-ray player, and then the receiver, the RX unit, goes by your TV.
Got it. TX and RX.
And crucially, both of these little boxes need their own power adapters. They plug into the wall. They're active devices, not passive.
Right, they need power to do that modulation stuff.
Mm-hmm. Precisely.
And that power lets you push the signal quite a distance, doesn't it?
Oh, yeah. That's the main benefit. We're talking full 1080p video, plus stereo audio, potentially up to 100 meters.
100 meters, that's what, over 300 feet?
328 feet, yeah, under ideal conditions. For that kind of range, you really need decent cable. Think RG6 dual shield or quad shield. That helps maintain the signal quality.
Good quality coax matters then.
Definitely, especially for longer runs. Now, okay, here's where people often get tripped up. We need to be super clear about this right away. This box is an extender. It takes HDMI in, goes over coax, and outputs HDMI again. HDMI to coax to HDMI. It is absolutely not a general converter. You can't, for example, plug the output from the receiver box into the old screw-on coax input on your TV.
Ah, okay. So it won't turn HDMI into like a channel 3 signal or something.
No, exactly. It's still HDMI coming out the other side, just further away. It also won't take, say, your cable company's coax signal and turn that into HDMI. Different job entirely.
That makes sense. Extender, not converter. Got it. So if it's not that, what's the biggest technical hurdle people hit when they try to use these? The main pitfall?
Signal integrity. Hands down. It boils down to this. You absolutely cannot have any standard passive coax splitters in the line between the transmitter and the receiver.
No splitters at all, like the ones the cable guy puts in?
None. Zero. It has to be a direct point-to-point connection. A single, unbroken piece of coax running between the TX box and the RX box.
Why is that? What do the splitters actually do to mess it up?
Well, those passive splitters, they introduce impedance mismatches, causes signal reflections back down the cable, and they drop the signal power significantly, sometimes by half or even more.
Wow.
Yeah. And when you're trying to push, like 10.2 gigabits per second.
Which is what HDMI needs.
Right. That kind of signal loss or reflection just kills the digital link instantly. So you physically have to find that direct line or run one and bypass or remove any splitters on that specific cable run.
Okay, so find that home run cable. That's the key. Direct connection.
Mm-hmm. And another small detail, the connectors on these extender units themselves are often BNC style, the twist and lock kind.
Oh, right. Not the standard screw-on F-type connector that's on most home coax cables and wall plates.
Correct. So if your house wiring uses the normal F-type, you'll likely need a couple of little adapters, BNC to F adapters, one for the transmitter end, one for the receiver end. Easy enough, but good to know beforehand.
Yeah, just avoids frustration when you go to plug things in.
So assuming we've got that direct line and the right adapters, what are we getting? You mentioned 1080p.
Yep. Full 1080p resolution. It also handles the necessary copy protection stuff. ATCP 1.1 is usually supported.
And it maintains that high data speed, 10.2 GBps, which means basically zero lag, no noticeable latency.
Oh, that's important for gaming, like if you hook up a PS3 or an Xbox.
Exactly. Or even just for channel surfing, you don't want that delay. It also carries standard PCM or stereo audio alongside the video.
Oh.
And there's often a handy little bonus feature, too. Many of these kits support what's called IR pass-through. 36 kHz is common.
IR infrared, like remote controls?
Exactly. Means you can point your normal remote control at an IR receiver near the TV, and the signal travels backwards over that same coax cable to control the source device.
Ah, so you could have your cable box or Blu-ray player hidden away in a closet or the basement.
Right, and still control it perfectly from the room where the TV is.
Yeah.
Very convenient for clean installs.
That is pretty neat. So compatible sources are basically anything with HDMI out then.
Pretty much. Roku, Apple TV, Blu-ray players, satellite receivers, cable boxes. Yeah. If it has an HDMI output port, you can likely extend it this way.
It really just solves that specific problem. Long distance, existing coax.
If we connect this to the bigger picture, the value here is knowing exactly what problem this specific tool solves. It's a wiring solution, a digital bridge. It's not trying to be a universal translator between signal types like HDMI and, old school RF broadcast signals. Different animals entirely.
So the takeaway is clear. If you need to get an HDMI signal from point A to point B over a long distance, and you happen to have a direct run of coax already in place.
A direct run, yes.
That's the key. Then this kind of HDMI over coax extender system could be exactly what you need. Just remember to ditch those splitters on that line.
Couldn't have said it better myself. Check the path, remove the splitters, use adapters if needed, and you're good to go.
All right, so here's something to think about. We just saw how understanding the difference between a signal extender and a signal converter is crucial for solving this specific wiring problem. What other, maybe similar, home tech challenges or infrastructure hurdles could you overcome if you just took a moment to really clarify the technical terms and figure out what a device is actually doing versus what you think it's doing? What knowledge gap are you bridging next?